Welcome to video 2 in the Input Analysis and Modeling module. In the previous video, in video 1, we introduced the notion of input analysis and modeling, and we used a particular example, the ATM example from the Kelton et al. Book that we see here, and noted that there were two metrics or two components of interest to us from this module's perspective. One is when customers arrive, we have the inner arrival time distribution, that we have is exponential with a mean of 1.25, and in the for the service time we have triangular distribution with parameters 0.25, 1, and 1.75. From an input analysis perspective, the question is, where do we get these values? So where do these expressions come from? In this current video, we're going to assume that we have some sample data. So you see some samples here in my Excel sheet. So I have an Excel sheet here that has, let's see if I can open the Excel sheet here. Right there. And so we have some observations, some number of data points that presumably have been sampled from the phenomena of interest. So the question is, given these sets of data, what are our options? How do we use the data? And we're going to look at several different alternatives. The first one is we can just use the actual data. So we can use the specific values in our model, the model. So in other words, I could just sample the either in order 1, 2, 3, 4, 5, and so on, or I could just randomly sample from my values. The second basic option is to develop a model. And we will look at two different alternatives for developing a model. One is using a theoretical distribution or a known distribution type. And the second is by using an empirical distribution. Whether it's a discrete empirical or a continuous empirical distribution, we'll look at those alternatives. For option 1, if we want to use the specific values, we can use Simio's input parameters feature to do this directly, and we will have a separate video for how to do this using the input parameters options. And so what we'll focus on for the remainder of this video, and then the next video actually, is on developing model distribution. So the first thing that we want to do in doing this is we want to look at our data. The first step here is to just observe our data. In particular, we want to do two things. We want to look at the descriptive statistics. So for our data, you can see that I computed the sample mean, sample standard deviation, and then the minimum and maximum for my values. And I'm also interested in looking at the histogram. So I want to look at the frequency histogram of my observations. So in this case, I have 1,000 different observations of my data, and I then came up with the range using my minimum and maximum, used the frequency function in Excel, in this case to get my distribution, to get my number of observations, and then I computed the frequency. And so what I'm interested in is just sort of the general shape of this distribution as a first part of trying to make this assessment of what type of distribution I want to use. And so I also have several other samples here. Let's see if I can go back to my slideshow, just to give you a feel for when we look at the distribution, what are we looking for? And so what we're looking for several different features here. We're looking for central tendency here, so we can see some central tendency here, you can see central tendency here, so on. In most of these we have that tendency versus uniformity that we see in this option over on the right. So this sort of central tendency versus uniformity is one thing we're looking for. We're looking for symmetry, or the opposite of skewness. So we can look at this distribution here and see that it's fairly symmetrical as opposed to this second one, which is highly skewed. This one and this one, data set 1 and data set 5, are also skewed. Data set 4 appears to be skewed, not quite as much as some of the others, but clearly skewed. So we're looking for the skewness or symmetry. We're also interested in the distribution tails, whether or not they exist. So for our distribution here, let's see if I can get rid of some of this. We can see tails way out here, and for this one we can see a tail down here. This one looks to have a hard minimum around 40. We see some tails here for sample data set 4. And so all of these things combine to help us try to assess what type of making a judgment of what type of distribution we want to use. So in essence, we're going to hypothesize sort of a basic distribution. And so if I'm looking at these distributions, let me erase all my marks here. This one appears to be triangular. This one appears to be exponential, or something related to exponential. This one's a little bit hard to tell, data set 3, possibly normal, a little what looks like to be a truncation here. So again, at this point we're just trying to make a basic assessment. This one appears to be triangular, maybe uniform. Maybe this one is log normal. So we have this bounded on the left side and then open on the right side. So this first step again is to sort of look at the distribution and try to make this initial assessment. So once we have an initial assessment, we have a couple of options from a model building perspective. One is we can just use our estimated values. So I could maybe for this distribution just assume that what I have is exponential. And I can actually build the model and do some assessment and do some analysis using that hypothesized model. At some point, I'm probably going to want to do some more detailed analysis of our input data to try to assess the quality of our distribution. And so in the next video, we will look at the primary mechanism that we'll use for assessing fit, or for determining the distribution for a set of data by comparing quantiles from our hypothesized distribution and our data.